So it has to be mixed signs in your final binomials. Zero always says error because, of course, you can't divide by 0. If you pre-marked one positive, one negative, make sure you put them in the right place.
Yeah, that's what my question was
Yeah.
going to be. Like, say that you just doing it wrong and
Yeah.
then you go to the calculator, that would definitely be the correct.
Yes.
Negative 18.
Correct. Yeah.
So you have to put the X on the left side and then Y2 on the right side?
What is your middle variable? XY. The variable specifically, middle variable is XY.
Okay, yeah.
So this, yeah. Because we're going to have something XY plus something XY will equal 6XY. So whatever our middle, this is our split middle, so we must use our middle variable.
Is it okay if we put the negative 18 first?
Yes, in fact, I recommend it in this case. You have a choice which one you use, and if you put the negative first, you avoid having that negative in the middle. Yeah. It's mathematically not wrong either way, but it's one less step when you're doing your 4-term grouping. Before I group, I make sure, yes, that adds up to positive 6xy. Okay? So I didn't change the value of anything. And because I chose to put the negative, because I have a choice, that keeps a plus in the middle, so I don't have to worry about negative GCFs and sign flips.
Okay, and you put 2x, it doesn't matter if that one is x squared and the other one is xy.
No, because they have at most 1x in common. So GCF is the most they have in common. This has 2 x's, that has 1. The most they have in common is 1. Yeah, if you try and take out x squared, then you'll have something left on the bottom here, and that would be bad. And with GCFs, it's either the smallest thing or smaller. And of course, FOIL to check. That's what's left behind after you factor out the 8x plus 9y, the 8x minus 9y. Okay. So the 2x got factored out, leaving behind 8x minus 9y, plus the 3y got factored out, leaving behind 8x minus 9y. So we went from 4-term sum to a 2-term sum. The GCF of this 2-term sum, the thing they had in common is 8x plus 9y, got GCF'd out. When that divides out, you're left with 2x in the first term and positive 3y in the second term. And to write it in a way this may be easier to look at, and feel free to keep writing it out this way, minus 9y. So here's our 2-term sum. 1-term, 2-term, and the thing they share in common is 8x minus 9y. Okay? So that divides out. If that's the GCF, that's 8. You have to write the GCF. It's part of the final answer. And when it divides out, what it leaves behind is Right. Remember, you always pull out your GCF and then immediately, boom, put up another parenthesis, and whatever's left over, 2x is left over here, plus 3y is left over here, whatever's left over goes in parentheses behind it, behind the GCF. Okay. So if that helps your eyes see it better visually, then keep writing it like that. That's formally how you cancel out the GCF. This is just my little shorthand. Okay. But you find the written strategies that work for you. Okay. You try this one. Mm-hmm.
We look for GCF
Right.
very first, and then, and then the second time will be down here, right?
Yeah, this to start off with up here, that was just an overall GCF
That's
before
what
you
I'm
made
saying.
any other decisions.
Yeah, that's what I was trying to do,
Oh, okay.
GCF first, but there's none right
There's
now.
not, yeah, so that,
then you go to the next step is
Mhm,
this, and
mhm.
then this, and then the fourth, and then, the fourth,
right,
and then the GCF again, so that you.
right, yeah. This at the beginning was an overall GCF, which there wasn't one here. So after you crunch your numbers to split your middle, now you're doing 4-term grouping, which is little GCF, big GCF. That's different from the overall. It's still the same skill, but it's not the overall GCF, it's the grouping method. Yeah. Okay. So what do you find? You're looking for 13? Oh, what happened? The numbers jumped up again. Now they're just getting really big. Did you find a 13 in the sum? Yeah. So is there any pair of numbers that multiplies to make 48? That adds to make 13?
3 and 16?
Yeah, no decimals. Yeah, we're only working with integers. What'd you say?
3 and 16?
Well, 3 times 16 does make 48. But your sign pattern is plus plus, right?
But it's a negative and a positive.
If it was a negative and a positive, that would work.
Negative 3.
Except that would make a negative 48, not a positive 48. Yeah. So you know you have to have two pluses here. So yes, 3 times 16 makes 48, but if they're both positive, it makes positive 48, but that would make positive 18 when you add them. And there's often confusing pairs like that. It's like, oh, they would work if the signs were different. So again, being aware at the beginning of your sign pattern is a good check. Yeah. 5s and 6s seem to work that way too. Is it 1 times 5 or 2 times 3? Yeah. And that's a bigger example of that same idea. Yeah. So the only way to get these two things to multiply to 48 and add to 13 is if this mixed signs, but then it would be negative 48. Yeah. So is there any pair that works with this sign configuration, two positives that add up to 13? No. So what do we say about this? Yes. And since we couldn't do anything, there was no GCF, there's nothing we could do. Yeah. That's all we can write, because we weren't able to write any even partial factoring. Okay. So let me jump into a couple new, well, one is kind of is a review from 308, but I'm going to really emphasize some things that are going to take you through 310 and into college algebra. And then a brand new method called substitution. Okay. So, first, take x plus 3, it's a binomial, and square it.
Is this still 9.3?
This is 9.2 still, yeah.
This is the second method, right?
Yes. It's another method. Now, it's not in the current 9.2. That's why you're going to see another 9.2 homework post. Okay. So this is a binomial squared. That just means a binomial times itself. Okay. So if you expand this out, And now FOIL it.
X squared plus 3x.
And then, and of course those are like terms, so x squared plus 6x plus 9. Now this wasn't just any two binomials multiplied, two different binomials. This is a binomial squared, a binomial times itself. So first, that means that your first terms in FOIL are the same thing. So your first term is a,
Squared.
anything times itself is a square. Now what about your last term? These are the same, right? So 9 is a 3 times 3. 3 times itself means it is 3.
Is it squared?
Squared, squared. The idea is that it's squared. If you look on the front end, f, x times itself, x squared. On the back end, 3 times itself, 3 squared. And 9 is a perfect square, because it has twin factors, 3 times 3. Okay? So the front end and the back end, the f and the l are both perfect squares. When you have a binomial squared with the same first terms and the same last terms, obviously because this is binomial times itself, the f, the front end is squared, and the l, the back end is squared. Perfect square, perfect square. Now look at the middle. The o plus the I, that's our sum. That is 3x plus 3x. Notice how those are the same, of course, because both of them have x's and both have 3's. So outside is 3x, inside is 3x. And what's another, just like we say a number times itself is squared, what is a number plus itself? Multiply times 2, or doubled is another way to say it, right? So a number times itself, like in F or in L, is squared. A number plus itself, like O plus I, is doubled, or times 2. Okay? Doubled or times 2 is different than squared. Okay? 3 times 3 is 9. 3 plus 3 is 6. 3 squared is 9. 3 doubled is 6. Okay? So when you have a binomial squared, a binomial times itself, that's the pattern that happens. Okay? So with that idea in mind, let's take x plus 5 squared, and without expanding and foiling it, let's multiply it. I want you to think of this not as a formula that I'm about to write out, but as like a mental foiling. Okay? So first, you're going to have x times x. What does that give you? Then you're going to have your outside and your inside, which are going to be the same thing. And what is your outside or your inside?
5x.
And then,
Plus 5x.
2.
right. So 5x, 5 times x, doubled, or times 2.
And then 5 times 5.
5 times 5, 25. Okay? So that's kind of a mental foiling. Okay? Try this one. 2x minus 3 squared. Now remember, when you are squaring something, this entire term, this entire first term is being squared. So 2x times 2x, the first one, 2x times 2x is, yes, 2 times 2 is 4, and x times x is x squared. You're squaring the whole thing. Okay? So the 2 is squared, and so is the x. So the first term is squared, because it's 2x times 2x. And the middle term is like 3 times 2x and 3 times 2x. So 3 times 2x is,
6.
specifically negative 6x, doubled. Because outside is negative 6x, inside is negative 6x. Negative 6x doubled. So 2x times negative 3, negative 6x doubled. And then the last terms,
Both negative 6 plus.
and positive 9. And they are both negative. They're either both positive or both negative. So your last term must always be
Positive.
positive, because when you have a binomial times itself, it's either 2 pluses or 2 minuses. Your C, your last term, has to be a positive always. If your C is negative, then that means you had mixed signs, a positive and a negative, and then it wouldn't be a binomial square. It'd be two different binomials. Even if the numbers were otherwise the same, if one's plus and one's minus, those are conjugates,
Can you
not
repeat again, how did you get the positive 9?
the positive 9, because this is, let me see, this right here, so if this is, if you look at it in expanded term, 2x minus 3 times 2x minus 3, okay? So you've got two negatives, right? So your L in FOIL, and negative times a negative is always, yeah. And same thing here, if this were x plus 5 times x plus 5, a positive times a positive is always, yeah. That's like reversing our idea of what our sign pattern is. If you have two positives, which a binomial times itself is either two positives or two negatives, then your last term must be positive. Has to be, yeah. Your middle term could be plus or minus, depending on whether it's two pluses, so your O and your I are both positive, or your O and your I are both negative. Okay? So whether your middle term is negative or positive tells you whether this is a binomial plus binomial squared or a minus binomial squared. But the last term will always be positive. The middle term will tell you whether it's a plus b squared or a minus b squared. Okay. Now when I just said that a and b, that's so you can see the algebraic form. So the algebraic form of this looks like this. So if you've got a binomial, and I'll just use a and b for the terms. I'm not using any x's or anything. The x's are implied. So a might be 3x or 4y or anything. Some first term plus another term, and that's a binomial and it's squared. Okay? Then the formula for that, though I don't want you to think about, oh my God, I have to memorize a formula. I want you to think of it logically, like mentally foiling. A times A. Okay? Then your O and your I is your middle terms, your O plus your I. So it's A times B doubled, right? Plus or minus. So 2AB. Double just means times 2, because you've got an AB plus an AB, so that's AB doubled. And then, always plus, because it's B times B. And for this one, that would be some term minus some term to make a binomial multiplied times itself, a binomial squared with minus a squared, a times a, mentally foiling, and then plus or minus. Yeah, because then we got AB, negative AB plus negative AB gives us, negative 2AB. So it's a times b, just multiply your a times your b and double it. And just make sure it's minus 2AB. Plus, remember, minus times minus, it's negative b times negative b, which is going to be b squared, but it has to be positive. Anytime you square a number, whether it's positive or negative, is a positive. And a binomial squared either has two pluses or two minuses. Okay. Now, I drew this arrow to multiply that out, mentally foiling, goes from this way. But remember, multiplication goes in two directions. If you're given this and told to factor it, and you say, hey, that's a perfect square trinomial, then I know it factors into its binomial squared. This goes in both directions. These right here, this side, these are what's called perfect square trinomials. And if you recognize, ooh, I have a perfect square trinomial, then your work is done. It's all in the recognition. That's what I have, so you know its factored form is a binomial squared. And this is, basically this is its polynomial form. Okay, so you're given a polynomial, which is a sum, and if you're asked to factor it, this is its factored form. Okay. So if you're given a perfect square trinomial and you recognize it, then all you have to do is write it in its factored form, which is the binomial squared. All right, so with that in mind, if you have 9x squared plus 30x plus 25. Now, those are some big numbers. So that should be your first clue, because remember what I said, and I'm admitting it, like factoring a not equal to 1 trinomials is the most tedious thing. Okay?
Is it an A or a 9?
That's a 9, yeah. Okay. So if you can avoid it, great. If you've got a shortcut, great. But I'm going to encourage you to do this. When you are multiplying out a binomial squared, do it the mental way. When you are factoring a perfect square trinomial, you can do it the long way with the ACB and grouping method. And you might say, oh, I don't think of this like memorizing formulas and then your brain crashes, I'll just do it the long way. No, do it the short way. Recognize what you have, put it right into this, not only because it's going to make it more efficient now, but because this skill, recognizing these and being able to do this, is very important moving forward in different contexts. We're going to use it again in something called completing the square later in this semester, and you're going to use it a lot in other contexts, even in college algebra. Okay? So don't resist this now. Don't just give in. It's like, oh, I'll just do it the long way. Okay? Do it the short way now, even if it's uncomfortable at first. Don't think of these as formulas to memorize, more as mental patterns. Get used to it now. It's going to make your life in several different contexts easier moving forward. So I see that as like, I could just do my ACB. I could crunch my numbers, ACB, and then do my grouping method. But if your eye recognizes, what do you have on the front and the back end? Perfect squares. Yeah. And that's positive. If this is minus 25, it wouldn't count, right? Yeah. So, your job then, this is your front end and this is your back end. So we're going to find our A and our B. And once we know our A and our B, we can test our middle term to make sure it really is a perfect square trinomial, and then we'll know exactly how to write our factored form. So since you recognize, your eye recognizes perfect square, then unsquare them to get your A and your B. What's my A here? What's this unsquared? 3x. Okay. And here, unsquare this to get my B. 5. Just 5, no x on that one. Okay. Now, that's great. My eye recognizes perfect squares, but it's not a perfect square trinomial unless this is also true. If the middle is AB doubled. Okay. Now, this one's going to be positive 2AB if it is a perfect square trinomial. So you're asking yourself, is this middle term equal to 2AB? I put a question mark because I don't know. I have to test it. This is where the work is. Test it, and if it is perfect square, then you're done. Okay? So you're asking, is this equal to 2, as in doubled, A, which is 3x, B, which is 5? Question mark. Okay? So if this middle term is equal to AB, A times B doubled, if this is equal to 30x, then check, you have a perfect square trinomial. 2 times 3 times 5. X. Check. Okay? So this is a perfect square trinomial, so your work is done. You don't have to crunch all those numbers and do ACB and grouping. Okay? You already know your A and your B, and if you have a perfect square trinomial, how do you write your A and your B? Yeah. A plus or minus B? Plus or minus? Plus, because this, if the middle term is plus, it's plus. If the middle term is minus, it's minus. Okay? So your factored form is 3x plus 5 squared. Done. The work was in checking it. When you checked it, you already have your A and your B. You stick it in your binomial squared. You say, oh, I have a perfect square trinomial. I know that factors into a binomial squared, period. No ambiguity about it. Huh? Okay. Try this one. 4x squared minus 28x plus 49. Right? So first thing is your eye should be, oh, I don't want to crunch those numbers. 4 times 49, that's a big number, and then it'd be a big mess. So, oh, perfect square, right? Now, knowing your perfect squares mentally, you can always check in your calculator by square rooting. For example, if you didn't know 49 was a perfect square, square root is above the square button over here. You get it to it with a second key, second x squared, 49. And if it gives you an integer, you're good, because that's like 7 squared is 49. We're going to have a whole chapter on radicals. Okay? But your basic squaring and square rooting will show you that this is a perfect square. Now, knowing your first 15 perfect squares is like knowing your multiplication charts, though.
Okay.
Yeah.
So it's
1, 4, 9, 16, 25, 36, 49, 64, etc. So, sorry?
No, go
Yeah?
ahead.
Yeah. Okay. So, what's your A and what's your B? What's your A? Right. You're unsquaring both your coefficient and your x. Yeah. And then your B? 7. Yeah. And you're asking yourself, is this equal to negative double A, B? Question mark.
Yes.
Yeah.
So you're going to show me 2x plus 7 squared?
Yeah. Negative 28x. Check. Yeah. And so now you already have your A and your B.
Why do you make it all?
Yeah, because it's either going to be negative 2 or positive 2, depending on that. But it's still 2AB or negative 2AB. Huh? You want to know, is this equal to, in this case, negative 2AB? That's the question. So you plug in you have negative 2 because you're doubling it, negative doubling in this case. Plug in your A and your B. Yes, that does equal negative 28x. And you already have your A and your B, so your factored form is 2x,
Plus 7
careful,
minus
minus 7 squared. Now I want to make sure I keep up with what I did in my 8 a.m. class, which is showing substitution method. But I just want to point out one thing real quick. I won't work this one all the way through. But say you've got 36x squared minus 132x minus 121. Perfect square trinomial?
Yes.
36 is a perfect square, right? And 121?
No, it's not. I had a calculator. I forgot mine. It is. It is. 121 is a perfect square. Isn't it?
Uh-huh.
It is.
Second square root, 121.
It is. 11.
Yeah. But that's not 121, is it?
Negative. What's that?
Oh, what's that? We're going to see that at the end of the semester. But that is not, and now mine is set to do I's. Most of them won't. So it actually would have, probably in yours, if you put that in, it's going to return an error, and it'll say non-real number. Okay. So if it says error non-real number, that's more common, what you see. The idea is that's I, or if it says non-real number, those are non-real. Can you have a negative last term for a perfect square?
No.
Yeah, 121 is a perfect square, and so is 36, but if that's a negative, it doesn't matter. Okay? Now, if this one were plus, you'd be good to go. You got to test this one, though. Is this 6 times 11 doubled? And that's what you test. And if it is, then you've got your A, which is 6x, and your B, which is 11. Okay? And if this is equal to negative 2AB, or negative 2 times 6x times 11, that's equal to negative 132x. And just calculate 2 times 6 times 11, negative 132, check. So so once you check that, okay, and that was one check, that these are perfect squares on the front and the back, and that this is plus. AB doubled, check. So this would be done.
So what would you want us to do? Just put minus,
No, if it is not a perfect square trinomial, you would need to do the AX, ACB, split the middle, do the grouping with big ugly numbers. Yeah. Yeah, because just because it's not, if this is a perfect square trinomial, its factored form is a binomial squared. If it's not a perfect square trinomial, it may still be factorable, but it won't be a binomial times itself. It'll be two different binomials. Okay. So if the answer on this was